Hey guys, welcome once again to this program of teaching and learning online. So today we are going to continue our lessons as usual. I hope you are staying safe to save your own life and for others. So, as you know, this program supports you to continue your learning, even if you're at home. You know that the school has been closed because of this pandemic. So today we are going to start another lesson. I've told you that I'm going to start a unit of physics. So I hope you will enjoy this lesson, and I find it very interesting for you because it is a lesson of physics. So let's start our lesson. Okay, good. As you can see on the display of the screen, our lesson will be a unit 5 of thin lenses. Thin lenses is a point, is a chapter that is studied in year 1 SME. Year 1 SME in the context of TTC is like a senior 1, senior 4 in general education. It's about optics. So let's start this unit. We'll continue. As you know, I am Sylvester Naganza. I'm your science tutor. Then I'm going to be concerned with this unit of lenses. Lens is optics. We will see lens. We use lens in many contexts in our daily life. This lesson can be also taught in option of ECRP. ECRP is ear childhood and lower primary education. Is an option found also in TTCs. So this lesson will be concerned with types of lenses and their characteristics. And their types. So let us start. As usual, I can show you the objective that I'm targeting after this lesson. I'm targeting to have learners that can outline types of lenses and their properties, their characteristics, of course, and they differentiate between lenses and curved mirror, because you know mirrors. They have done mirrors in senior 3 O level. How they reflect light. Now we're going to be concerned with lenses. We will be able to differentiate those two materials. My contacts are the following. You can contact me for any support, for any addition, for any question. Also, you can contact me. Very soon, I will display I will show you all materials that I use in this. In preparing those lessons, and even those PowerPoints that I'm used to show some ideas in my lesson. So you will be with them very soon. I'm still opening a blog so that you can go there to take those resources. So let us continue. We are going to start with an activity. To refresh your mind, we are going to start with an activity. So you are going to observe the image below and answer the questions asked. So the first one is this. The second one is this one. And the third one is this one. Observe it very well, and you are going to answer some questions. As you can see, there is an image A, image B, and this is image D. This is called the D. It's not displayed very well, but it's D. You can observe it very well, and you will answer some questions. On D, I see there are some lenses, some types of lenses. So, hope you have observed this very well. So, I can proceed. So, can you name? The first question is to name images A, B, and D, and identify where they can be used in real life activities. Where do we use image in A? Where do we use image in B? Where do we use image in D? So, what is the effect of light on those objects you found in image A, B, and D? When light strikes on the surface of those images, what happens? Do you remember what has happened? When light strikes the surface of those images, those objects in images. So I can continue with those questions. Predict the materials used to make the above lenses. Picture D. I've told you in D there are lenses. Hence, can you predict the materials that the industry used to make those lenses? How are the lenses different? All images, all lenses you found in image D are the same. They look the same. Is there any differences? So classify these lenses according to your observation and explain the criteria used to classify them. You can classify them by your own. So, as you can see, those are the questions concerned with this activity. Maybe you have written somewhere on your exercise books so that you can try to think about it. Let me start again, once again start on the images so that you can write it very well. You see, there are image A, there is image B, there is image also D. D is the lens. D was not indicated, but D. So observe it very well. I give you about 30 seconds to observe it. Make your observation and see what is there. Time is elapsing. So, the first question is this one, second is this one. You can write it somewhere and concentrate on it. I give you about 2 minutes. 2 minutes is enough to accomplish this activity. Name image A, B, and D, and identify where they can be used in our real life activities. What is the effect of light on A, B, and D? Other questions. Predict the materials used to make the above lenses. In picture D, how are the lenses different? The last one. Classify these lenses according to your observations and explain the criteria used to classify them. Hope you will be very creative on these questions.
Satana ngota aripima basizawe utadose Oinaje wese Najungiri ushaka Ukanimbea
So we are finished to discuss about those questions. So now we're going to share observation. Going to share observation of what we have seen. We will compare our own that we have written down. We will compare them with mine. I'm going to display my observations are the following. For question A, CA is a star side mirror. Have you seen that? It's a star side mirror. What do we use star side mirror in our rear right? It is used in cars so that the driver may look back. Means that the driver may look back what is behind without turning himself, or can drive it back to pass the car. You see wrong, but he can see also what is happening in his back or her back. So B is the magnified glass. The magnified glass sometimes is called hand lens in laboratory context, but is a convex lens that is used to produce a magnified image of an object. See, when you zoom out with magnifying the glass, you will see the status will be somehow big. So it means that it magnifies the size of the image. So D is what? Is different lenses, as I have told you. So a lens is an optical device which transmits and reflects light by converging or diverging the beams. It means that it will explore it very deep in this lesson. How they have these properties of transmitting and refracting light by converging or diverging the beams. This is our concern in this lesson of today. So on B, I have observed that lenses and mirror are affected by light when they reflect them and deflect them. Here is very you have to pay attention because they reflect and they reflect. Respectively means these lenses reflect light, means they do reflection. Do you remember reflection? Hope you have seen it in Corel, but I'm going to remind you a little bit by using some animations. So, lens reflect light. When light strikes on lens, means lens they reflect it. What is reflection? We are going to be concerned with it. So, mirrors reflect light. They reflect what? They reflect light. When light strikes on the surfaces of mirrors, light is refracted. diffraction and reflection. So we are going to explore those terms through animations. We're going to see animations that explain reflection and the reflection. You will see, even after we ask you some questions, you will differ. You will differ those terms, reflection and the reflection. So I have here some animations that is going to help us. I have here some animations. So I'm going to start with reflection. Reflection. What is reflection? This video is going to explain you in summary, but in a good way, what is reflection.
Reflection of light. Reflection of light. Have you observed the path of light when it strikes the mirror or wall in daily life? Does it move along a straight line path or changes its direction? Definition. When light rays strikes the boundary of two media, such as air and glass, a part of light is turned back into the same medium. This is called reflection of light. A highly polished surface, such as a mirror, reflects most of the light falling on it. Laws of reflection. 1. The angle of incidence is equal to the angle of reflection. And 2. The incident ray, normal to the mirror at the point of incidence, and the reflected ray all lie in the same plane.
So this is deflection. You see, the light meet an obstacle. You see here there is a torch. As you can see here, there is a torch. That is a source of beams of light. It releases the light, and then the light cannot continue in this way, in the same ways like this. Means that this light meet obstacle and then it reflects back. This is what we call the reflection. Reflection means that light remain in one medium. Means that it strike and meets an obstacle and then it return back. This is what we call reflection. It's done by what? It is done by the mirrors. Mirrors, light cannot pass through the mirror. Mirror is an opaque object, means that it is not transparent. Opaque means not transparent. The light, when it strikes on a opaque object, it returns back. It cannot pass through. When it passes through, it becomes another phenomena that is called reflection. I want to see what is reflection now. I think you have understood what we call reflection. Reflection means that it is done by opaque objects such as mirror, where light strikes on it reflecting surface and then it returns back in the same medium. The law of reflection, you have seen it, or incident rays and the reflected rays. This one is reflected rays, this one is an incident ray, lie in the same plane. And there is a normal, which is a line which is perpendicular to the surface of reflection, which is the surface of reflecting surface of the mirror. And the angle of incidence, which is the angle between the incident light and the normal, this angle here is the angle of incidence, is equal to the angle of reflection. This is another rule. I think you have used them in senior 3 in O level. You have discussed this a lot, to remind you. Okay, now we can continue with what? With reflection. This is another process I have told you that is another process that I'm going to show you. Also this video.
Refraction of light. Have you observed the path of light when it enters from one medium to another in daily life? Does it move along straight line path or changes its direction? Let us observe some of our day-to-day experiences. For example, wet pencil, partly immersed in water, it appears to be broken at the interface of air and water. A clear pool of water always appears to be shallower than it actually is. A coin placed at the bottom of beaker containing water seems to be raised. When a thick glass slab is placed over some printed matter, the letters appear raised when viewed through the glass slab. Why does it happen? Let us understand the reason with this illustration. Let us consider a water tumbler and a pencil. When the pencil is partly immersed in water in a glass tumbler, it appears bent or broken to the observer. We know for a fact that the pencil is not bent at all. It just appears to be so. In this case, the light reaching observer from the portion of the pencil inside water seems to come from a different direction compared to the part above water. This makes the pencil appear to be displaced at the interface. Does the pencil appear to be displaced to the same extent if instead of water we use liquids like kerosene or turpentine? Will the letters appear to raise to the same height if we replace a glass slab with a transparent plastic slab? You will find that the extent of effect is different for different pair of media. These observations indicate that light does not travel in the same direction in all media. Definition: when a light ray travels from one optical medium to another, it suffers a change of direction at the surface of separation of the two media. This is known as refraction. Activity: suppose we were to place a coin in a glass of water. The light bouncing off the coin underwater, for instance, would have to first travel through the water and then the air to reach an observer's eye. At the boundary it gets refracted and reaches the observer's eye, thus appearing to be slightly raised.
Good. You have seen that through this video. You have seen that when the light is traveling from one medium to another, means that here there is two medium that are separated by what? By a transparent material. Is not an opaque material such as glass, such as water. You see, on the surface of separation, this light will suffer what we call the change of direction. So this is caused by what? By changing medium. It comes from one medium which can be low dense or high dense and enter into another medium. So this is called the reflection. Means that reflection, there is two media. There is two media where the light is going to pass through them, and when it enters the second medium, it suffers from the what? From the change of direction at the surface of separation. When this happens, this process is called what? It's called the reflection. Reflection of light. You see the differences between reflection and the reflection. So I think you have something in your brain now. I think I tried to remind you what you have done in senior 3. So this is what we call what? This is what we call reflection and reflection. So those process happen when light strikes what? The surface of what? Of lenses and mirrors. All of them happen when the light strikes on lenses. What happens is reflection. When light strikes the surface of mirror, what happens is called the reflection. I think you are familiar with those terms. Okay, so now I can continue. So now I'm going to start. I think We are still in activity. I'm going to answer question C so that you compare with yours. Where lenses are made from? I think it was the question C. You have seen that lenses, they are made from crown grasses. They are made from crown grasses, flint grasses, and modern days lenses makers use what we call quartz particles. Quartz are materials that you can find also in I think this is what we call those precious minerals are minerals. Quartz, I think here in Rwanda also we dig quartz as a mineral, and acrylic plastics. There are some plastics that are very transparent. We use them also to make those. They use them to make those lenses, and this material may be used in a combination. You will see some lenses that are made from a combination of different materials among this one. So those are materials where lenses are made. You see, this activity is like a new resource. It also provides you with new knowledge. Did you know that quartz crystals can make lenses? Lenses, do you remember those materials you use to correct your aberrations, your eye defects, like myopia? Those materials, accommodations you get, those I know it's like a Linnet. Linnet are some of materials made from what? From lenses. So on D, how do they differ? They differ in shape. They differ from their shape and also from their focal length. You'll see this focal length in deep with their properties, their focal length, and also their shape. You have seen that their shape are not the same. If their shape are not the same, this will affect their focal length. Their focal length is the half of the center of curvature. I think you have seen it on mirrors in your 3 lessons about optics. Is a half of center of curvature when we are making something like those mirrors. Mirrors also are spherical, and you will see also the lenses will be also spherical. So the shape affect their difference, and also their focal length affect their properties and their differences. So the last question was about how to classify them. They are classified in 2 ways, concave and convex, depending on their shape. I've seen that they are different from their shape. So shape is a good feature to differentiate what? To differentiate those lenses. So some lenses are concave, others are convex. Remember this point. We're going to start in deep this. Okay. So let's start. What is a lens? Many of you were there without knowing what you are discussing about. What is a lens? A lens is an optical device with or approximate axisymmetry which transmit and reflect light by converging it or diverging them. Beams, you know, is a set of rays. You remember that, you have seen it in whatever. Beams is a set of rays that is going in a given direction. So a lens is an optical device which have approximate axisymmetry, exact axisymmetry, which transmit and refract, means transmit from one medium to another, but it reflect, it change, it affect the direction of light in a given way. You will see by converging it or by diverging it. So lens in a smaller na small na short, it can be defined as an optical device which transmit and refract light by diverging or by converging it. But this property of axisymmetry is also has an exact axisymmetry, so that it cannot change it approximated to be there. Perfect, very perfect. So let us move. So characteristics of lenses. What are the characteristics for those lenses we are talking about? Characteristics: lenses are spherical. I have told you they are spherical like mirrors. They are spherical. You see some of them, they are half or part of quadrat of spheres. They are spherical. Their two surfaces are part of the surfaces of a sphere. I'm going to draw it here. They have two parts, which is a part of the surfaces of sphere. The curved surface of the lens is called a meniscus. So you will see here, this is what I'm talking about. The two curved surfaces is what is called the meniscus. Meniscus here. You see, meniscus. Let me use this one. Yeah. Here they are meniscus. Meniscus means what? Means the curved surface on the lens. You will see there are parts which are curved on the lens. So let us move. Lens forms image of object by reflecting light. Means that the process that we use in lens, the process or phenomena that happen in the lens when light strikes is reflection. Reflection means that reflection is a process that happens when light is struck on lenses. So the light ray changes the direction after passing through the lens. Means that they suffer from reflection. So they are reflected. This is the reason why we say reflection, because they change the direction when they are passing through. They pass through. It's not reflected, but they pass through the lens. Means that the direction is changed when they strike the surface of what? The surface of the lens. So types of lenses. Let us move very quickly. Types of lenses. There are two types of lenses. Two types of lenses are convex lens and concave lens. I have told you before in the introductory activity. I've seen that there are two types. There are convex and concave. In concave, we'll find subtypes, and in convex, you'll see also subtypes. So the main types of lens are convex lens and concave lens. So convex lens, we are going to start with convex lens. Convex lens is a lens which is thinner at the center than at the edge. Up to now you not yet see the image of a lens, but here you can see it. Like this, be convex. Is thicker at the center, but it is very narrow at the edge. Means that the lens in this form is called a convex lens. A convex lens means that a thicker, as you can see here, is very thick. And here you see is the thickness starts to decrease when we are going up to the edge. The lens in this form is called the convex lens. So when we are tracing rays, we will see in the reflection of light through lenses in the next lesson. on this unit. We symbolize it like this when we are tracing rays by using this lens, the convex lens. Or convex lens we will do like this in ray tracing. We will do like this. This is the axis unit. We will do like this when you are going to trace ray diagrams by using those convex lenses. Or convex lenses, we will refer them by using this sign, because drawing this can take time, but drawing this is very easy. Try it out by your own pens. You will see this is very fast. So this is a symbol used to refer to convex lenses. So let us move. A convex lens we are going to explore its property. The convex lens is usually called what? A converging lens. Why? You see the term here, converging lens means that it converge what? It converge light beams. You see, when light passes through a lens, reflection occurs at the two lens surfaces. Means that you can see that the ray from a convex lens on this shape, you can see it, are getting closer and closer to a point. When it passes through, those are parallel beams. Those are parallel rays, you see. When they pass through this lens, they will start to become closer and closer to a point. This is what we call converging. Means that convex lens is converging lens because it converges beams of light on what? On the same point. You see, on the same point. This is what we call converging lens because it converges right at the same point. So we continue with the main types. Don't be confused. We are going to see the concave lens. Concave lens. Concave lenses. Lens which is thinner at the center, but they start to be thicker when we are getting to its edge. You see here the concave lens is totally different from the convex one. You see, is thinner in the middle, but in the center. But as we go to the edges, it starts to be somehow big. It starts to be thick. The shapes, the lenses in this shape are called the concave lenses. We refer them like this. When we are going to trace rays, we refer them like this. Means that you do like this. When you will see in many books, they refer to them like this. They refer to them like this. Means that they is a common symbol that we use when we are ray tracing. We are tracing rays. Okay. So, what about it? Concave lens is also called the diverging lens. You see how they reflect, right? You see, some is converging and this one is diverging lens. Diverging lens means that you can see here on this chart, you can see that the refracted ray from the concave lens is spreading out. Means that is diverged. Is diverged in different directions. So this kind of lens is called diverging lens. Means they diverge light. They spread out what the light beams. Okay, you can examine this. You see, the rays are parallel. Means that the rays are parallel. When they strike the surface of lens, they start to be divergent. You see, they were parallel, but here they tend to go to different directions. We will explore it very well when we start the next lesson. The second lesson after this will be concerned with the reflection of light through lenses. This will give us many rules that we follow when we try to trace rays reflected by lenses, both diverging and the converging lenses. So the reason why we see people say there is two types of lens, diverging lens and converging lens, is the same as saying that there are concave lens and the convex lenses. So let us move. Let's explore each part. Now we are going to start with convex lenses. We're going to see the subtypes of what? Subtypes of convex lenses. Subtypes of convex lenses. So, convex lenses are the following. They are a big convex lens, the one I have showed you, and plano-convex lens, and also converging meniscus. Those are three common types of convex lens. Meaning in main type, which is convex, there are some subtypes. Those subtypes are big convex lens and plano-convex lens and converging meniscus. So, big convex lens. Let's start with the first one. Big convex lens. Big convex lens are thicker at the middle. They are thicker at the middle, we have seen, but as we are going at the edge, the thickness starts to decrease and become thinner. So, big convex lens are converging lens. The right ray passing through it are brought closer together. Means that it converge at the same point as we have seen here. As we have seen in this point. It means that the converging lens do this. They converge, as you see here in this figure. They converge parallel beams to the same point. Is what means converging. So let's move. Means that the big convex lens converge right because it's a converging lens. Okay. So their symbols are this. I told you before. They are biconvex. This biconvex, this subtype biconvex, their shape is this, but the general symbol for convex is that one. When you're going to trace rays, you will refer to this point, this one. Okay, let us move. Let us move to plano-convex lens. Plano-convex lens, they have positive focal length. You will see on the picture, they have one spherical surface and one flat surface. Meaning that you see the focal length is placed in a positive place. When you try to trace the number in here, you know that here is negative, here is positive. You tend to here positive, infinity, negative. You see, saying that the focal length is positive is because it is placed here in the side of positive infinities. So here is this focal length is in positive side of the lens. So you see, according to their shape, they have spherical, you see, is a spherical, this is a spherical surface, and here is a flat surface. As you can see, it's a flat surface. So those are explanations that I give you, or that I can give you, plano-convex lens. So let us move. Plano-convex lens, you will see it like this in different books. So there is also converging meniscus. Those are three subtypes on convex lens. So converging meniscus is also called the concavo-convex. Concavo-convex, you see, as you can differ on the picture, concavo-convex, you see there is a convex here surface and also there is a concave surface. The reason why it is referred to as concavo-convex. And hence that is concave on one surface and convex on the opposite surface. You see, one is concave, one also another one is convex. So let me be very quick. So the types of concaveness. The types of concaveness is the concaveness, plano-concaveness, and also diverging meniscus. Diverging meniscus. You will see this one, it has some similarities with concavo-convex, but there is some little difference. You will see it on the shape. So, concave lens is biconcave lens, plano-concave lens, and diverging meniscus. Those are the three subtypes that you can find in concave lens. So, let us continue with biconcave lens. We start from the first Sabu type. So, they are thinner at the middle. They are diverging lens. You see, here, other than being converging, they are diverging. It means that they are diverging as they are concave lenses. So, this is the first one that we have talked about. It means that they diverge beams of light in different directions. They spread them out. And also the symbol that we use in ray tracing is this one. This is the symbol that we use in ray tracing. So they diverge beams of light. You see the incident are parallel, those red ones, and they are divergent. And the image, how to trace the image, I will teach you in the next lesson. So let us continue with plano-concave lens. Plano-concave, these lenses are thinner at the edge than in the center and flat at one surface, at one side. So they are diverging also. You can see here they have one surface which is concave, you can see, and here is what is a flat surface. This type of lens is referred to as what? As plano-concave. When you see this shape, you may say that is a plano-concave. So they are diverging, they diverge right. You will see it in the next lesson how they reflect right. So diverging meniscus are convex-concave lens in which the power of the concavity exceeds what the convexity. You see, this property is called the negative meniscus. They refer to as the negative meniscus because of this. Their convexity is very low with their concavity. Means that when they are refracting ray, they follow the property of concave other than convex. So their convexity is low compared to concavity. You see. So the reason why you see that main difference I have told you, there is something here. There is some distance here. It's not like a meniscus. That concavo-convex. It's not like the one was like this. When I tried below, it was like this. There is no distance between two surfaces, but here you can see there is a distance between two surfaces of lens. So those are the three types. The subtypes that we find in concave lenses. So maybe you are familiar with it. You will also, you know that you can download those videos on YouTube. You can play it and replay it so that you understand very well without me. I am very hurry so that this video can take tomorrow a small time or moderate the time. So let us move. The cross section of 4 different thin lenses. This is the assessment. I'm going to proceed with the assessment. You know that after all lesson, I left you some activities so that you can exercise yourself. You can do some exercises. So the next slide will be concerned with the assessment. The assessment, you can assess yourself and see if you understand those types of lenses, their definitions, their characteristics, and those processes of refraction and reflection. Okay, so let us move with the assessment activity. You can see this. The cross section of 4 different thin lenses are shown in the figure below. I show you different lenses. I need you to observe it very well, and then you can also draw it. It's very simple. You can draw it somewhere A, B, C, D, and then you answer for the following question: which of these lenses, if any, are convex or converging lenses? Which of these lenses, if any, are concave or diverging lenses? Why do you make such decision at A and B? Give your point of view, your supporting argument, so that you focus on to take this decision of your response. So, also the second question: make a deep research on where these type of lenses are used in our daily life activities. I will come in the next lesson. In the next lesson, I will come showing you how those lenses reflect what right. Thank you for your listening today. Maybe you have tried to work. I tried to make this lesson interactive by providing you with activities, but as you know, I'm remotely with you. I'm in long distance with you. The reason why I'm providing you this remote program. So this remote lesson hope will help you to continue revising or taking new knowledge and competencies. So let's stop here today. I will come in the next lesson. But don't forget to click subscribe, because when you subscribe, you will get the update lessons immediately after we make it. Means that you will be very updated with our lessons. I will share you a link in the next video. The link that will show you a blog where we upload all of those materials we use in the teaching. Maybe it will facilitate you to read or to download it and retain you in your documents on your device, or you can print it also and have it like hard papers. So thank you, stay safe and stay home.